Hello and welcome to another Python Basics tutorial. Today we're going to introduce the concept of empty values. And it's important to note that basically all programming languages have something like this, but it's not always the same name. So you might have heard of null before, but in Python the value is called none. So why would you need an empty value? Well, meet Carla. Carla is a cow like any other, and we also have Antoine, he's here. And in our program, we can't just put a cow in, right? So we want a way to describe this cow. So how will we do it? We can do a dictionary. So we will give the cow a name, which is going to be a string. So Carla or Antoine. We're going to give them color, which is also a string. We could just call it brown and black. And then we have a sex. Carla is a female and Antoine is a male. And they both have a horn length, which is a float. So for Carla it would be 10.5, for Antoine it would be 9.5, for example. And now we have a problem. Meet Anna. Anna is also a cow, but she doesn't have horns. So how do we represent this in our code? The question is, do we give a 0? And because she doesn't have a length, right? So 0 would be appropriate. But now if you read the code of someone else, do you say 0 means she has no horns? Or does 0 means the horns aren't long, so they're just really tiny, so they're 0? Or were they cut off, for example? You don't really know for sure, right? But if you have none, then you know she doesn't have horns. So in this case, you could give none if she doesn't have horns, or you give 0 if the horns were cut off, for example. And this makes things more clear. And generally, there's a lot of cases where you really would like to have a none value. So most programming languages, they have one. Another important concept is mutable versus immutable types. So this is basically different types have mutability or immutability. So we're going to start with immutable ones. You can think about it like this. If you have your variable, which is called Carla, then you can assign it to a value, for example, an integer. In our case, we're going to take a cow. And now if you want to reassign this, then you can't just change Carla a bit. You can't take her horns off or something like that. You have to change the whole value. So if you want to give a new value to Carla, your variable, then you need to replace it completely, right? And now your Carla variable still is named Carla, but it points somewhere else. And then we have mutable ones. And here you can think about basically the concept of a list, but instead of a list, it's going to be a stable in our example. And now your stable has 2 cows. And now you can see the stable variable points to the stable and there's 2 cows in it. And now if you remove one of the cows, so if you remove Helga, she's going to go away and it's still the same stable, but it looks different. Okay, so nothing changed from the object that the variable is pointing to, or the object wasn't replaced, but it changed. So it's the same object, but in a different state. Now, how does it look in code? So here we have an example for the immutable type. And here you can see basically our 2 variables, an integer, which is in the normal scope, and then we have the integer in function, which is inside the function. Okay. So now if you have Carla again, here you can see the integer basically points to Carla. And if we give this into the function by calling it, this integer in function, it also points to Carla, because Python uses something called pass by reference by value, I think it's called. You can look it up how they pass it, and different program languages do this basically differently. Make sure you understand the concept of this. And now what's going to happen? You can see in here we assign a value 4 to this variable. So what does this mean in our example? This 4 is basically our other cow Helga. And now this integer in function is going to point to Helga. And now you can clearly see that the old variable, an integer, is still pointed to Carla. And now if you check the print statements, you can see it remains unchanged. Okay, even though we pass it, if you reassign in the function, it doesn't change it. We could also give the same name. We could also call it an integer, but the scope is different. So you can see it doesn't change because it's the reassigning is in the function. Okay. And now, if you look at the mutable idea, you can see we use a list here, and we have the list in the function. So what's going to happen here? You can see we have our list, and we have basically the stable from before, and we have our 2 cows inside. And now you can see our A list is pointed to this list basically, and then we pass this reference basically, and the listing function also points to this. Okay. And now we're going to execute this pop function, which is just going to remove the last element. And now what's going to happen? The cow is going away. But now you see that A list is still pointed to the same list as before. So it also changed. So now you can basically understand why before the function call we have 1, 2, 3. And even though we have a different variable name inside the function, it's still going to affect the variable outside of it, right? So basically not the variable, but the list outside of it. Go over this if you didn't understand this. Make sure you understand this concept. This is really important. So here, if you print the list down here, we're missing one element, basically the last one. So another very cool concept in programming is loops. And with loops, we don't mean this funny looping stuff, but it's more something like this. Basically automation for things that you always do the same. So loops basically allow you to execute code multiple times. And you basically know it already, the concept, just by a different name. So list comprehensions that you learned before, they're basically for loops, so to speak. Maybe they're implemented a bit differently, but the concept is the same. So you can see here you have an example where basically we do the same thing with a list comprehension and with a for loop. So here you can see in the comprehend list, you just say, I want to do this for each element in my list, right? And then you see it's gonna add 1 to each element. And with a for loop, you do it somewhat differently. You say for each element in my list, and then in the body of the function, basically, you say I want to do this and that. And then it's gonna execute it for each element. So you can see we have the same outcome. It's just, looks a bit different. Go over this, see if you understand it, and then you can basically know how this comprehension of lists works. So basically, for loops is the basic, list comprehension is the fancy application of it. So what do you use for loops for? Basically, looping over stuff. So you either use this if you have a collection, so for example a list or a dictionary, and you want to go over all elements, or you can do it for a range of numbers. So for example, I want to go from 1 to 10 and do something for these 10 things. So you can also use it for if you know how many times you want to do something. Like for example, if you want to do it 10 times, you can just do 1 to 10, right? And if you think about it, there's this range function. I think it's going to get introduced in the next lecture. Think about how this range function is different from elements in a collection. And if you think about it, read the documentation, then you're going to see it's basically the same thing. But it feels different, but it's the same in the end. And it's basically good for, if you want to do something for all the elements or do something X times. And if you're going to look at code in the real world, you're going to see loops everywhere, right? Loops are very essential. They're very cool. You're going to need it all the time. So if you see code base and it doesn't have any loops in it, then it's probably bad code. Then we also have while loops. While loops are a bit different. So they don't give you the notion of going over elements, but instead you give a condition. So basically you say while, and then you have this condition here. And this is going to execute and execute and execute until this condition is false. So it always reevaluates the condition, and it's going to see, is it true, false, is it true, okay. Then I'm going through the loop, is it false, okay, I'm stopping. And you could see, basically, we have this looping value 0, and then we're going to just add 1 to it until it's bigger than 2. And now we would see it prints 1 and 2, and this is basically how it works. So why would use a while loop? Basically, the reason why you use it is if you want to do something until a condition is not satisfied. I think this can be For example, if you have a user interface, this can be good. For example, until you close the window, you want to do something, check for inputs or something like that. And yeah, this is also what it's good for, just doing something until condition is met. There's somewhat different philosophies. Some people say you shouldn't use while loops. I think they have their place, but you just need to know when to use them. And the problem with while loops is they can run forever, right? And so this is a really important thing. And hope this is not you, because in the end, if your condition is never met, then it's just gonna loop and loop and loop, and you don't know what's happening. And there's sometimes your IDE or the debugger has something built in that it stops after like 1,000 repetitions. But if you don't have this, it's just gonna run forever, and you have no idea, is my code just slow, or is there a while loop that's just terminated? And the last concept for today is ternary operators. And they're basically a cool feature which is aimed at to do this. So basically it can improve the readability of your code, but they also can make your code harder to read. And I'd say they're somewhat controversial. So some people really like them and other people really don't like them because you don't technically need them. They're just, it's called syntactical sugar. So it's just, yeah, it's a different way of representing your code. And now you can check this out. Basically here you have this ternary things. I'm gonna go to it in a second. And here you have an if, elif, else loop or condition. And if you look at the lowest ternary condition, this is exactly the same as the condition from the if, elif, else. And now please, if you have multiple options for the same code, always choose the readable one. Don't take this by heart. It's not always. Sometimes you need like this extra performance or something. But if the code does the same in the same speed, choose the readable version because you want people to understand your code, and it's really important. Because if you want to change something, you don't understand your own code, yeah, good luck with that. So how does this ternary operator work? Basically, you have a variable, and then you want to assign this value. But now you want to give a sort of a second option, which you can basically do by giving this condition and then the second value. So all it does basically is it assigns the first value to your variable if this condition is true, and otherwise, if it's false, then it's going to choose the second value. So basically it's just, is this condition met? Yes, then do the first value. Is it not met? Then do the second value. And it's really handy. In the beginning, you might not have very much use case for it, but you're going to see a lot of it where you want this basically. But remember, you can always use an if condition instead of this ternary operator. And now for the lower line, you can just verify, try to understand this lower line, try to understand the if conditions, and then you can see that it's basically exactly the same. And now you can see this. Basically, this is why I said it's somewhat controversial. So not all people agree that it's better or more readable. And yeah, try to find some threads, why it's good, why it's not. Try it in your code, see why you like it, why you don't like it. And then in the end, it's it's a matter of personal taste. And there's also a short notice about this. Basically, I'm gonna call this tech is opinions. And so how it works, basically all developers, this is how they usually work. Whenever something new comes, some people are gonna like it, some are not gonna like it. And I found this very interesting thread. Maybe you heard of Windows 11, this new feature that they have, which is called Recall. And basically what it does, it makes screenshots of your file system to help you and assist you and so on. And there's a very interesting thread where you can read up with some users giving very interesting opinions. And yeah, I'm gonna link this, and if you want to laugh at it, you can check it out. And here are all the things that we used in this video. You can check them out as well. But yeah, I hope you understood something and could take something away from it. And yeah, we'll see you in the next video.